on behalf of Vishwasamudra to present today's lecture or presentation about what we are doing, especially on new technology for road construction in India. As you rightly mentioned, we're diversified technology, infrastructure company, doing irrigation projects and dams and excavation works apart from buildings as well. I'm focusing totally on new technology for construction of roads, and I've been doing this for the last 4 years since the inception of this technology. We've been constructing using this technology over the last 3.5 years in India, and I will give you a presentation on the same and look forward to intense participation on the same. So I'll go ahead and first I'll give you a short video about our company and what we are looking at, and then slowly take it from there.
Sir, it is not audible, sir. Sir?
Yes, sir. So just a small video about where we're heading to as a company. If you see the impact on environment over so many years is huge because of use of aggregate and other resources, natural resources that we need for construction of roads. If you look at the last 5 years, almost 40,000 kilometers of highways and 60,000 kilometers are planned for the next 5 years. And this is only the highways. If you look at the link roads, if you look at the state highways, and if you look at the village connectivity roads, PMJSY, and various other organizations building, we are talking about huge numbers of kilometers. So if you take all that into consideration, it's a huge loss in terms of aggregates, and we're losing hills and a lot of other resources. So our goal is to try and reduce as much as possible using environment-friendly technologies. And we came across this technology in Germany over the last 4 years back, and that's how we pursued it. If you look at this particular slide, we are intending to save anywhere between 80 to 90% of aggregates.
कोशिश करे कि कैसे प्लेऑफ से बाहर हो जाए। खैर मजाक छोड़ते हैं, एक जीत दूर है बैंगलोर प्लेऑफ से, केवल एक सिंपल बात है, बैटिंग में एबीडी या चीकू में से किसी एक को या दोनों को अच्छी पारियां खेलनी पड़ेगी।
हेलो सर, कैन यू हियर मी?
Yes, sir. Yes, sir.
Yeah.
Some other voice was coming from the participant. He has muted now, sir.
Okay, sir. Yeah, so we're looking at saving anywhere between 80 to 90% of aggregates while construction of our roads. So impact on environment, if I go through, mining of stone aggregates, of course, involves a huge quarrying and stone processing equipment, particulate emissions, thereby causing air pollution, and which again which leads to removal of natural vegetation, and again existing wildlife has to go to a narrow area because we're using up the forest space. And so here what we're trying to do is as much as possible not use fresh aggregates with our technology. Transport sector is one of the leading contributors of greenhouse gas emissions. If you take transportation wise in terms of construction as well as in the movement of vehicles, we're talking about 14% of India's CO2 emissions. So government of India is planning to expand a national highway to almost 2,000 kilometers in the next 5-year plan. If you look at the progress this year itself, I think they've touched close to 40,000 kilometers. So it's a huge expansion, and we obviously need a lot of resources. The government has also launched a Bharatmala Pariyojana, which aims to build 66,000 kilometers and even more to connect the expressways and the ports and different infrastructure projects. They also have this Sagarmala and other programs which are coming up for good connectivity of roads, which helps to boost in the economy of the country. So these lead to large-scale emissions and implications on environment sustainability, which require very proactive steps. And so the government is now focusing on reduce, reuse, and reinvent, and that's where we've fallen. And recently, government has taken a lot of steps to see how new technologies can be implemented in construction of roads. They've already made a draft, the Ministry of Road Transport, under the Honorable Minister, Mr. Gadkari, and he is very, very keen that new technologies play a very important role, starting from DPR stage onwards. That circular should come out very soon. And introducing road construction by soil stabilization, full depth recycling does not require stone aggregate or sand for preparation of base and sub-base layers. They have previously as well, Ministry of Road Transport has come out with certain environment-friendly initiatives. I think 2015 they came out with a circular where it says that if projects are finding difficulty in implementation because of lack of aggregates, they can ask the government to go for new technologies. And a few contractors have asked the government to change this policy. Especially, a lot of states like Kerala has banned mining, so they have to get from outside, typically Karnataka or some other state or Tamil Nadu. So, which is getting into huge cost overruns of the projects. Also, Northeast, there's a huge problem with aggregate. Uttar Pradesh, Bihar. Andaman. So all these states have problems or are in the process of banning mining. So this is where we feel that new technologies will play a very important role. So I just want to give a brief on stable road additive. So basically stabilization has been there for so many years. It's not new. It's been there for maybe 30 years in different parts of the world. Last maybe 7-8 years, we also tried slowly in India. they've done with limestone. They've used cement. They've used fly ash to improve the subgrade or increase the CBRs on a different scale. So how we are different is this particular product which we import from Germany has very good properties, which is helping us increase the CBR values to a great extent, and also giving flexibility to the surface of what we are doing. So this is a German company, and the other important aspect is we are using very high-end equipment. So the entire process of road construction is mechanized. So that helps because there's hardly any human interaction while laying the road. Entire thing is mechanized, and which leads to very, very good compaction. So that is giving us very good strength and durability as well. So a stable road is a cement additive which makes the layer semi-rigid yet maintaining flexibility due to its ability to form interlocked crystal structure to fill whatever pores are there in between. So due to the sealing of the micropores, it makes the pavement impermeable to water, acids, chemicals, thereby making it very strong, durable, and also very high load bearing. It retains excellent dimension stability even in damp and humid conditions, and increases the elastic modulus of pavement, eliminates the risks of shrinkage cracks, thereby enhancing flexural strength and significantly increases the life of the pavement. Stable road is manufactured by B&K Industries, and it is at 100% natural. It uses 100% natural minerals with no synthetic chemicals. And it's been tested in various organizations in India, especially Indian Institute of Toxicology in Lucknow has tested it and have given their report as well. So stable road is being used in different parts of the world over the last 20 years. And we have got it to India about 4 years ago, and we have the exclusive rights for this product in India and in other countries around India. So one major advantage is a very fast laying technology. So typically conventional method or a cement road takes anywhere between 2 weeks to 3 weeks or 4 weeks to complete 1 lane kilometer, especially when it comes to cement. And so by using our technology, we can do almost, if everything is planned and logistics are good with cement, we can do almost 1 lane kilometer per day of stabilization. So after 3 days, we can go for a layer of BT on top. So pretty much in 3 to 4 days, we are done with 1 lane kilometer. That's how fast we can do. And once we stabilize it, if there's an emergency, we can allow traffic within 6 to 7 hours. But ideally, we would like anywhere between 12 to 15 hours. So there's no issue with allowing traffic if it's a rural road, or if the road is very there's a lot of traffic in city. We can allow traffic within 6 to 7 hours. Stable road has been accredited by Indian Road Congress, and we've been, like I said, we've been using it for more than 3 years. Soil stabilization and full depth recycling. Basically, soil stabilization is a process binders additives are added to the existing soil to change the engineering properties of soil. So this we have done different projects in India. We have done greenfield projects, and that's where we use soil stabilization. Full depth recycling is existing pavement. We rehabilitating the existing pavement by just mixing cement and additive. So we're not removing or wasting any portion of the road. So usually we scarify it and remove 30%, or in some cases we use 30% of the asphalt to use it for recycling of the bitumen. So here we're not removing anything. We're using the same surface, and we're stabilizing the same. So typically we are following IRC SP 89 Part 2 2018, which basically shows the guidelines for design of stabilized pavement. So there are about 3 main factors which talks about SP 89. One is the stabilized base layer should have a minimum compressive strength of 4.5 to 7 MPa. The second is the durability of stabilized base should be tested by wetting and drying for 12 cycles. Maximum permissible weight loss after this procedure is 14%. Residual strength of the specimen after this test shall not be less than 20% of 28 days UCS. A commercial chemical stabilizer has to be tested for toxicity and leaching by CSIR, IITR Lucknow, which we have already done. So, and if the product passes the above tests with reputed institutes like CRRA, IITs, NITs, Indian Institute of Toxicology, then it can be used. So in our case, from the beginning, CRRA has been with us. They've tested our roads from the day we started our technology. It's been 3 years. We just finished one road, actually 2 roads after 3 years. CRRA has tested it actually 2 weeks ago. So the entire process of 3 years has been done as with regards to testing for strength and durability as well as FWD. So I'll share those reports over the progress of this presentation. So benefits, some of the benefits of stabilized pavement is native soil can be converted to base course, reduction of excavation, disposal and transportation, reduction in crust thickness, faster construction, increased lifespan and low maintenance cost. So if you see the life cycle cost will be definitely much lower than the conventional roads, and the cost saving in the long run. That's what I meant for life cycle. If you see also, sir, the load bearing is, if you see general conventional roads, the load is on as a point, it's on one point, whereas in the case of stable road, the load is being spread across the road. So that helps in giving us a better life cycle. The highlights again, as like I said, one more important thing is a reduction in thickness of pavement. Because our layer is so strong, the modulus is pretty high. So because of that, using IIT PA, we can bring down the thickness of DBM and BC to a large extent. Yeah. So far we've done about 200 lane kilometers, and if you see the graph, the slide here, we have saved almost 83% of natural resources. So we've saved almost 360,000 cubic meters of stone aggregate, which is equivalent to almost 26,000 truckloads. If you take the emissions and carbon emissions, all that, if you add up, that's a huge saving that we have done so far. This slide basically tells you a typical construction procedure using our design. As you see, the entire thing is mechanized, starting from spreading of cement to spreading of additive to recycling to compaction to grading. So the entire thing is totally mechanized. So we're having excellent quality, and there is no chance of trying to save on the parameters of cement and all this. So if you see, after we finish rolling, we need typically we need about 3 days of curing. Traffic can be allowed, like I said, within 12 hours. Curing goes on when the traffic is there. On the 4th day, we can go for a layer of prime coat and then go for a BC on top. I'm going to share a small animated video just to explain how the machine works, and then I'll show you another video about how the technology is, a brief video, and then here we're spreading cement. There's an additive spreader which is not here, but then water is being pumped into the machine. This is just a small animation. Show the actual video. We have done it in two roads. First part shows you Greenfield Road, which we have done in a port where the volume was very, very high. We measured and we're talking about more than 200 MSA of traffic. And the other part of the video shows you a road we have constructed in Hyderabad city, in the center of the city, existing BT road. So please go through the video. We've taken a core after 28 days. Here we went up to a depth of 40 centimeters. We haven't used one single stone of aggregate. The second part is the road in Hyderabad. If you see, this is existing BT. It's just spreading cement on top of the road. We haven't scarified anything. Yes, sir. So now projects that we have executed so far is around 200 lane kilometers in different parts of the country: AP, Telangana, Kerala, Punjab, Bihar, Andaman. So we are jointly working for construction of 400 kilometers of rural roads in Andhra Pradesh. This is funded by Asian Infrastructure Investment Bank, AIB. So we have started work and we've completed close to 100 kilometers so far in different districts of Krishna, Kadpa, Anantapur and Kurnool. We are presently executing 80 kilometers of road in Andaman for NHIDCL, around 37 kilometers of road in Bihar for Ministry of Road Transport as a national highway. 15 kilometers for UPEDA. They're constructing two expressways, Purvanchal and I forget the other name, but we're doing about 15 kilometers for the service road. So once it's been tested and proven, we intend to use this for the main expressway as well. We're also executing the rehabilitation of Hyderabad International Airport run by GMR. So we're doing about 2.4 lakh square meters using our technology. Some highlights I quickly want to point on with regards to CRRI and IIT. So apart from CRRI, we also tied up with IIT Roorkee and IIT Chennai. IIT Chennai has already done a report with, we're in touch with Dr. Virragan as well. And IIT Roorkee with Professor Ransang Chung, and they've been doing work with us for the last 2 years. Coming back to CRRI, so basically according to SP 18.9, the UCS after 28 days should be 4.5 to 7. In the lab in CRRI, they've got a strength of around 5.88 on average. But actual on site, we have achieved 10.2. So, this we observed in almost all the roads we have done so far, where the test results is much higher than what we're achieving in the lab. The durability test, all cores have passed the durability test the last 2 years. Now, the third year, we've sent the cores to CRRI just yesterday. So they will be testing for durability for the third year as well. So I'm sure most of you know about durability. It's 12 cycles. It's 48 hours each. I think 42 hours they put in an oven and remove it, put 5 hours in water and then brush it up and do it. So this has to be done 12 times. And after you finish it, they check for the weight loss. If you see the next one, there's a permissible is 14% weight loss. In our case, if you see from CRRI, it's around less than 1%. And on site, it is around 1%, 1.1%. And this has been the case of all our cores so far. Again, if you remember, we talked about residual UCS after the durability test. It should not be less than 20% after 28 days. So in our case, actually, it's gone up. The cumulative fatigue damage test also has been done, and it was 0.35. Toxicology, like I said, it's been done by IITR. These are the various roads CRRI has tested. The first three, or if you see the average UCS after 28 days was 10.3. The next year, and the durability also is the same, around 3%, maybe 4%. These are other roads that we have achieved the UCS after 28 days. We are all well above the norm of 4.5%. So this is the leaching and toxicity test that I just mentioned from Indian Institute of Toxicology. They tested it for toxicity in various areas, and 0% immobilization was observed after 48 hours. So stable road cement stabilizer is considered safe. Apart from IIT Chennai also has tested for leaching and toxicity, and the report is also there. So I'll quickly run through all our projects that we have done with pictures quickly. This is the works we're executing at the airport in Hyderabad, GMR. It's actually there are two runways. Each runway is 4 kilometers long, and width of one runway is 45 meters, the other is 60 meters, and the taxiways as well. So stabilization we have used in, like I said, close to 2.5 lakh square meters. We're still in the process of doing. We finished, I think, around 80,000. The balance is on the main runway, which will be starting by December 1st. The cement we used is around 25 kgs per square meter, and stable road was around 1.2 kgs. This is because there was already a lot of aggregate at the bottom, so the surface was relatively strong because a lot of aggregate. So we used less amount of stable road. So these are the pictures in situ stabilization. We spreading cement and then recycling, and then. And then we went for a SAMI layer. So we used the chip spreader, which is again totally, automated. It comes through that chip spreader layer. First we put PMB 40, and then laid the chips on top of it, and then rolled it. So the consultant for GMR asked us to do two layers of SAMI. So we did two layers, one on top of each other, before going for SDAC and DAC. These are the cores taken, and we got a strength of on an average of 8.28 after 28 days. This slide shows what is the existing conventional crust before we did the stabilization. So there was 125 mm of BT followed by the FCR and GSP. So GSP remained the same. We didn't go up touch the GSP layer. We did stabilization of 250 mm. So residual FCR was still there, about 80 mm. And then we went for 20 mm of SAMI layer, followed by BT of 125, which includes SDAC and DAC. That was for taxiway. For runway, this is how it's going to be. We're going to a depth of stabilization up to a depth of 350 mm, followed by SAMI and BT. This is going to be the main landing area and the main runway. So here we saved about 75% in aggregates. So the works executed under MOAT and NHI and HIDCL. We did a road in Bihar. This is in Sitamarhi. Jayanagar stretch. So here they had a lot of issues with aggregate. They were not able to get aggregates to the site. So that's when Ministry of Road Transport asked us to find a solution, and we went and did that. Its total stretch is 37 kilometers. The first phase is 20. We finished around 13 kilometers so far. So we used around 40 kgs of cement and 1.4 kgs of stable road. Here we went up to a depth of 300 or 30 centimeters. So if you see the soils, there's an existing road. Of course, the soils are very sandy and very different typical soils. So we have stabilized here up to a depth of 300. This is how it looks after stabilization. And then, so here we used a geosynthetic as a SAMI layer. Basically, since we're using cement, they're bound to have certain superficial cracks on top. So this is to arrest the cracks coming into the BT layer. We have gone for the SAMI synthetic paving fabric. So on top of that, we spread the BT. So here we haven't used DBM because the traffic is less than 20 MSA. If you see here GSB, and so we've gone for 300 mm of stabilization followed by SAMI. Oh, I'm sorry, I think we did use DBM. It's a national highway. I think it was 40 MSA. So we used a DBM of 50 and then BC of 40. Here again we used again, if you see 78% reduction, but the aggregate, what you see, the usage is mainly for BC and DBM. The actual stabilization part, there's hardly any aggregates that we used. These are the cores in Bihar. The next road is a road we're doing in Andaman, which is a length of almost 70 kilometers. Here again, we used about 40 kgs and 1.4 kgs of stable road. So here, Andaman has totally banned aggregates. So people constructing have to shift aggregates from the mainland, and it was costing a huge amount of money. So under the guidance of Honorable Minister, suggested that we use this technology in Andaman. So 2 or 3 people were asked to try the technology there, and we have got the highest length, almost 80 kilometers, and we have completed close to, I think, 16 kilometers so far. And we have saved, using technologies, we have saved almost 350 crores for the government because of shipping of aggregates. So this is the road before taking up the work, and we're spreading cement and the additive, and this is after stabilization. They were gone for a chip seal and then went for a layer of BC on top. This is a chip seal and being rolled on top of it. And this is the finished wearing course. Again, we've gone up to a depth of 330 mm or 33 centimeters, followed by SAMI and BC. Here, if you see, we've saved almost 90% in aggregates. The traffic was 20 MSA, and UCS we achieved was around 8.9 MPa after 28 days. The course. So existing road, there was some aggregates, so that's why you see aggregates here. Otherwise, per se, we haven't added any aggregate. Whatever was there, existing soil, we just churned it. This is a road for PWDs. You just saw the video. This is in state of Telangana. This is the road that you just saw after 3 years. It's the same. They haven't, this road was actually getting damaged. That's why they asked us to do here every year. There's a lake here, and so it was getting damaged. So it's been 3 years and not a single rupee has been spent on maintenance. Another road in Hyderabad. These are the cores in Hyderabad. This is the core. On the left, you see the core after 28 days. On the right is the latest, about 2 weeks ago. When CRRI came, they've taken these cores, and this is after 3 years. And if you see, the UCS value has gone up a bit. This is the durability. So if you see, the absorption is less than 1%. This is the compressive strength over the last 3 years. We've also done FWD for 3 roads. This is one of the roads. Along with CRRI, monitored by them. So basically FWD is, I'm sure most of you, everybody knows, impulse loading device, which is a transient load applied to the pavement, and the deflected shape of the pavement is measured. So basically we're measuring the deflection using, so here we typically, they used, I think, 60 kilonewton to 80, the weight is being dropped on the pavement surface and is giving a reading. So I'm happy to say that over the last 3 years, the reading has been exactly the same. So basically shows that the surface below the pavement has not been affected at all. And, the strength remains the same, and it should last for a number of years at the stabilized portion. Another slide on the same FWD, if you see quickly, the conventional layer, the bitumen layer is 2411, the elastic modulus. For us, our layer bituminous was 2300. But if you see the base layer, conventionally it was 485 elastic modulus. In our case, we've cost, average was around 7,000, which gives you an idea of how strong the base is. Average deflection value, if you see, is almost half of a conventional road, 0.094. At the bottom, again, if you see the tensile strain at the bottom of bituminous layer and compressive strain at the top of subgrade are less than limiting strain requirement of 80 and 200 microns as per IRC 37 for long life pavements. So if you see tensile strength for stabilized pavement was around 25 or 26, tensile strength was around 30, and the vertical compressive strain at top of subgrade was around 90, which is very well within the norms or even less. So which gives you an idea that how strong, and this is after 3 years. So it gives you an idea of how good the layer is. Again, the Hyderabad roads we saved around 92%. This is a road we did in Kerala. If you remember, there were some floods about 2 years ago, very bad floods. So they asked us to come and do one stretch which was badly damaged. Here we used about 30 kgs of cement and 1.2 kgs of additive. So this was how it looked. Almost the entire road was full of potholes. And so like I said, we don't scarify it. We don't do as it is. We spread cement on top of it. We spread the additive, recycle it. And then we compact and then give you 3 days of curing. Now this is how it looks, the surface after 3 days. I mean, very strong as it is if you look at it. Then we spray bitumen on top and go for the laying coat. So here in this particular road, traffic wasn't great, so we didn't go for any DBM. We went straight for the BT. This is almost 2.5 years ago that we did in Kerala, and it's still holding very good. These are the cores again. If you see here, entire depth of existing WBM was there. Entire depth we went for stabilization of 300 and then went for a layer of BC on top. This is the road we did in Punjab, your home state, Laldu to Handesra, close to Chandigarh. So this is how the road was on the left hand side. And this is after it was finished, the same stretch, exact same location. I took a picture. If you see this slide, almost 3-4 kilometers was like this. A lot of potholes, impossible to go. And this is how it was after we finished. Since we go up to a depth of 30 centimeters, we didn't add any aggregates or any soil on top of the existing road which is on the left. Since the machine goes up to 30 centimeters, we just went ahead and recycled as it is. So we didn't add any materials to it, and so this is how it was. Now I think it's become very busy, this particular road. If somebody can have a look at it, it'll be nice. This is the finished portion. In fact, 3 kilometers of this road is full of quarries. So the road was very badly damaged. So you can even go have a look even after 2 years. I mean, I think it's about 1.5 years. You can still go. There's absolutely no damage to the road. You can see the number of vehicles going and the quarries and all that. This is the core. Again, we got an average of 7.2 MPa. The local, there was a professor, I think it was Dugal, and Professor Dugal, who came and monitored this road construction. So this was a 20 MSA road, and we've got an UCS of 7.21. Now I come to rural roads, Panchayat Raj, like I was mentioning, state of AP. So here some roads were BC soils, some were good clay, good soils. So it's not the standard for every single road. This particular road, what we did was a BC, so we had to use a little more amount of cement and additive. Again, very good strength. Actually, in rural roads, we follow IRC 72, which requires a minimum strength of 3 MPa. But in our case, we have achieved much higher. So we'll, over a period of time, we have to reduce a dosage of cement and additive to get the optimal. It doesn't make sense to use so much material as well. So we're working on it, and this is the strength. Again, CRRI has tested this road 2 weeks ago, and this is the strength they have achieved. It's actually gone up. Again, FWD was done on these roads. So very interesting. There was a national highway done by Dilip Bilcon, which is adjacent to our road. So we actually did a comparative, just to see how stable road versus a national highway, which has I think DBM of almost 80, 90 mm of DBM and 45 BC. And of course, since this is a national highway, the other GSP WMM, the thickness was close to around 400. So we just did a comparative study. CRRI just wanted to do it, and this is a comparative study. So again, if you see the base layer, we have got close on an average modulus was around 6,800 versus a base layer of national highway was around 470. The average deflection was very similar to the national highway, much better than a conventional road close by. And again, within the norms, if you see. These are typical, like I said, these are funded by Asian Infrastructure Investment Bank. So they are doing almost 5,000 kilometers of roads in AP. Out of that, we are doing around 400 kilometers of stabilization using this technology. They are typically around 3.75 meters with roads, connecting rural roads where there are hardly any roads, or the roads are very, very badly damaged. So this is really, a game changer for connectivity of roads for people living in remote areas. And it's been 1 year since we started some roads, and even after these heavy monsoons this year, there is not a single road which has been damaged. So this is the next segment is private port industries. I was talking about this is where we first did about 3 years ago. This is Krishnapatnam Port. So this was the first project in India, and the quantum of traffic was very huge. Like I said, it was touching I think 220 MSA, and we are talking about almost 3,000 trucks to 4,000 trucks every single day on these roads. Coal laden, fertilizer, name it. And so here we went up to a depth of 40 centimeters of stabilization. We used 60 kgs and 1.8 kgs of additive. Just happy to say that in 3 years, not a single rupee has been spent on maintenance of these roads. You can check with the port authorities as well. It's holding up very well. These are the roads after 3 years. This is the core. On the left is after 28 days. On the right is after 3 years. So if you see, it's exactly the same. If you see, this is a greenfield road. Not one single aggregate we have used on these roads. No DBM. We went straight for BC because we also wanted to test how it performs, and absolutely fine. Just if you see, there's only a layer of BC on top. This is again tested by CRRI. If you see, the absorption of water after durability is around 1%. And these are the strengths over the last 3 years. It's gone up. Again, FWD was done on this. If you see the values of deflection, the deflection is very, very minimal. These are the roads after 3 years at various locations. We've also done specifically on one point for the S-curve. We wanted to test if there'll be any rutting or undulations because the loads are transferred when the vehicles are turning. And we found that there's absolutely no undulations or rutting. These are the kind of vehicles, like I said, this is a road right next to the berth. So very heavy loads, and it's holding very good. There's another road we did in a sugar factory. We did another road in a port in Adani, Adani Katpalli. There's a port, so we did some roads here as well. So it looks. So here we used carted earth, which is also actually they do dredging. So we use that particular sand to save on using other material, and the strength is pretty good. These are the cores. Yes, sir. That's my presentation, and hope. Hope it was interesting for you all. If there are any questions, my colleague is here as well. Nagendra, he's done his MTech from IIT Mumbai in pavement engineering. We can answer any questions if you have.
Thank you, sir. I request the audience, if you have any queries, please put in chat box as well as you can ask. Sir, there are some questions already.
Yes.
What will be the cost of construction for 1 kilometer for road, F4 road using this stabilization method?
Yes, sir. So again, it's not a constant, sir. It depends on 2-3 factors. One is the traffic. Second is the condition of soil. So these two are very important in coming to what is the cost. But typically to give you a ballpark figure, there's a big range. I mean, a rural road, I can construct anywhere between 45 to 50 lakhs to a highway to around 90 lakhs, 80 to 90 lakhs, or even more. If the MSA is very high, then obviously it goes up. But my main point here is I definitely can save a lot on DBM and the BC layer.
Okay, sir. And also he was asking, compare the cost with the conventional method. So what is the...
Right, sir. Like I said, I'm sure will be cheaper in most of the cases, especially where there's a problem with the aggregate. I'm sure it will be much cheaper. But on the whole as well, even if in some roads we are on par or even light, but you also have to consider the pace of construction and also the life cycle cost. So if there's hardly any maintenance, like I said, you see in the kind of traffic in the port, every few months they were repairing it or patchwork or relaying it. It's been 3 years. So if you see the life cycle cost, it's a huge difference on the total cost project. But coming back, yes, we'll definitely be cheaper if the distance aggregate is much further. Even on a regular road, if you take the pace of construction, yes, if you take all those into consideration, will be cheap.
Okay, sir. On the participant, Mr. Deepak asking, what is SAMI? SAMI.
So
somebody already responded. Yes, sir. Stress absorbing membrane interface.
Right.
Yes.
It's laid between the BT and the stabilized layer. So basically, like I said, there will be because we're using so much cement, there will be some small superficial cracks for the pores. So this basically arrests those cracks from going into the BT layer, which is according to the code. We are IRC has a specific code for this, and we are following them.
And also the same participants, Ravi Teja asking for arterial roads. I think he want to compare the arterial roads cost with the conventional methods or something, sir.
So the question is not clear. For arterial roads, what do you mean?
Yeah, Mr. Ravi Teja, are you there? If you are there, please open to ask.
Yes, sir. Just now sir said like rural roads. He said no, sir.
Yes.
Cost will be compared with the rural roads. I'm asking for arterial roads, sir.
Yeah, for arterial roads also. It applies to arterial roads also. What sir has said, it applies to arterial roads also.
Okay, sir. Thank you, sir.
Okay, also the material for membrane they're asking.
Yeah, for SAMI, we will be using fine chips and bitumen.
Yeah, so the two options, sir. Like in the airport, you saw we are using chips with PMB. In Andaman, we using I think VG10 with those chips, and in the road in Bihar and the road in UP, we are using this geo something. Yeah.
Okay, sir. Any questions from participants, please?
Sir, I have one question.
Yes,
please.
Yes, sir. As you discussed that it is a eco-friendly material. So,
Yes.
sir, can we go for some other material instead of cement, like fly ash and baggage ash, whatever? So we
Yeah.
can save cement also. Have you done something to avoid cement, to use of cement?
No, we haven't we haven't used anything with fly ash. As of now, we are only using OPC 43 because it helps in giving us a good bonding and also fast setting. So we're only using OPC 43 as of now. Only in Bihar we used, I think it was PPC if I remember. I'm not sure, but otherwise generally it is all OPC 43. We haven't tried with other. Because our technology, it has certain properties and is doing very well bonding with cement. So we just continue with that. But yes, we will try. I mean, we have our own lab now. We have a lab in Estonia in Europe. So we're trying different combinations and see what is the best for us.
Okay, thank you, sir. Thank you.
Okay, any questions from anybody else? Yes, sir. Some more questions. Maybe you give you can give a try with a double coating, like with emulsion and foam as well.
Okay, so they do use that, sir. I mean, emulsion and foam, they have tried in stretches in UP. So that they use a bitumen tank and they use existing surface as well. That's slightly different from what we are. So there they actually scarify the material and use some of the material and bring it back, and they use that foam bitumen to do the roads. They have been doing that, I think, last 3 years in India. We haven't tried. Ours is a slightly different technology, so we haven't done that.
Okay. One more
So
question.
the air void's impact on that.
Yes. How about the air void's impact?
Yeah. So if you see, sir, I mean, we are using 3 rollers. So the first one is a 20-ton sheepfoot roller. That's also being imported because we want very good compaction. In our technology, it's very, very crucial that we have very, very good compaction, and we're achieving almost 96-97% of the compaction. So there hardly any air voids, and like I said, that's the reason we're getting much better strength when compared to a lab. Or even when we test the soils before we go onto the road. So our strength we're achieving much higher because there's hardly any gap. And the durability is there to see. I mean, if you take the core and test it for durability, the absorption is 1%, which you're allowed up to 14%. So that itself shows how good the compaction is and how stable road is helping, the surface to bond well.
Okay, sir. Any questions? Any more questions, please? Yes, sir. One more questions from Mr. Rishi Singh. With emulsion and foam is what known as a cold in place recycling. This technology is soil stabilization technique. Both are doable.
Yes, yeah, that's like I said, we just discussed this earlier. That's the same foam that you're talking about.
Hello.
Yeah.
Actually, sir, it's not my question. I am giving a reply to Dr. A.
Okay, okay, okay.
Okay. Okay, thank you. And next question from Mr. Ravi Teja. Have you tried Sassobite additive for bitumen layer? If it is, what is the significant change in strength?
Sir, bitumen layer, we are working on it, sir. I mean, bitumen layer is, of course, as it is, we are using whatever is there in the market. We typically use VG40 or DAC. But we are trying to tie up with some players in the market to use plastic waste. So that will also help us because as it is, we are working on environment friendly technology. So adding plastics to bitumen, we are trying to see, further enhance the savings in environment. So actually, we are in discussions with very big players in the market. Hopefully, if we get that, we tie up with them, then we buy the bitumen from them, which is again saving on cost of bitumen as well as saving on the environment on fresh things. So we're working on it, sir.
Okay, sir. Some more since I think Rishi, we are on the team who initiated this techniques in Canada. Okay, I think only response.
Yes.
Next, has this technology been tried in cold areas like Himachal? If yes, where? This is
not yet, sir. We haven't tried in the cold area, but like I said, we have tied up with IIT Roorkee, and they have done the same durability test using a course using the cold cycle. I mean, if you see previously, we've done the putting it in the 12 cycle. They put it in oven. In this case, they put it in ice, freezing temperature. I think it was minus 20 or 30. I don't remember, sir. But they've done the process in IIT Roorkee, and it has passed the durability test there as well.
Okay, sir. Yeah, I think we can wind up the session, sir. No more questions, I feel. Let's move on to vote of thanks. On behalf of the organizing team, Department of Civil Engineering, I would like to thank our speaker, Mr. Srinivas G, our Director, Viswa Samudra Engineering Private Limited, from the industry for the sparing his valuable time and sparing the useful informations on the insights in light of development of new highways using the recycling technology. I would like to extend my sincere thanks to the Director, NIT Jalandhar, as well as the Professor Head, Department of Civil Engineering, for their valuable input for conducting this series. I would like to extend my sincere thanks to all the participants from various parts of India for listening the webinar patiently in light of the series. With this, I conclude the webinar, and I request all the participants to attend next lecture by Mr. Satish Kumar Danwar, Regional Head, Ultratech Cement Limited, Punjab, which will be held on 7th November 2020, 11 a.m. Thank you. Take care. Okay, thank you, sir. Thank you so much.
Thank you, sir. Pleasure. It was my pleasure, sir. Thank you.
Yeah, thank you so much, sir. Dr. Raji will contact you, sir.
Thank you, sir. Thank you.
Yeah, thank you, sir.
Yes, sir. Thank you, sir.